Okay, and we are apparently live. Let's see
Yay.
if let's see if that is actually working. Yep. Okay, awesome. So, hello internet, welcome. Today I'm going to learn Kubernetes from scratch. I'm joined here with Netanel Haber, if I'm saying your last name correctly. Uh,
Yes.
okay,
Haber.
and what?
Haber, I guess, in English. Usually Haber.
Haber, really? I'm not. Haven't heard you ever introduce yourself. So maybe you should start doing that right now.
Okay. So, like you said, my name is Netanel Haber. Um, I have been working for about 3 years, just about as a like a programmer professionally. And the last year I've done a bunch of cloud, a lot of Kubernetes, a lot of like native cloud applications. I didn't sign up for it, but I was forced to in my job. So I guess that's the best way to learn usually. And let's see what else. Um, I like JavaScript. There we go.
You probably even like TypeScript better, if I recall correctly, but
But JavaScript needs more defending than TypeScript. So
that is correct. Yeah. So, all I know is that I need to learn Kubernetes. I know that I want to provision something for myself, and that you know the way to somewhat do it, but not all the things. So we're going to start with actually trying to provision like a Kubernetes cluster on the cloud, because we're not going to go the Minikube route, because I'd actually want to use this in production, and the Minikube is not production ready or meant to do anything like other than toy implementations of Kubernetes. So Terraform, yeah,
well, no, Terraform is for provisioning
yeah, the
machines
yeah, yeah,
and resources.
yeah. I thought about provisioning the cluster through
Oh, like the
Terraform.
actual cluster through Terraform. Yeah, okay.
Yeah, that's that was my plan. Yeah, so let's go over to the tutorial. I think, is this like a good place to start, or do you think we should start somewhere else?
No, I think the Terraform official tutorial for the GKE cluster sounds like a good place to start. Yeah.
Yeah, and we can also start with going to the Google Cloud. Let's pick, yeah,
Project.
infra. Yeah, some projects. Infra sounds like a good place to shove this in.
Yes.
Uh,
Oh, there's a
and
create a GKE cluster button. Do you see that?
yep, but we're not gonna click things here because first of all,
Filter.
it failed to load. But that's just, what is it about like cloud consoles, really? Like, when has it ever been like a good thing? Uh, Suits
AWS
infra.
does it better, although uglier, but better.
Really?
What is failing to load though?
I'm not sure, because it's even failing to load like here the project. Yeah,
Oh,
so we are on SUF's infra, and then we clicked on the official link here, and this failed to load. And then we're refreshing, and then it serves the sidebar, but now it's not. Oh, now
okay.
okay, so we might want to enable some stuff. Let's actually like run over this. This will probably lead us through enabling all the APIs that Google can bill us through.
Yes.
Yeah, this is by the way, like this is completely going to cost me money, and I'm okay with that, and that's fine. Like I'm not
It's
afraid
like
of
$10, whatever,
10 cents per hour apparently.
Yeah. Yeah.
Um, so should we read everything? Like, this is going to deploy a two-node separately managed node pool GKE cluster using Terraform. This GKE cluster will be distributed across multiple zones for high
Don't really
availability.
need multiple zones doesn't I mean, all of our production environment is on literally one zone. Like you don't really need multiple zones, but whatever. Okay.
Yeah, I didn't think so. I thought like US East and not think about it so much. Like US East Center or something like that. Like the smallest availability zone that is just, the one that's like built up to, be the highest loaded zone in the world, probably.
If you were building Netflix, then we would have a different conversation, I guess. All right.
Probably if we were having Netflix, then probably it wasn't you and me having this conversation.
No, probably not. Okay.
So yeah, why deploy with Terraform? Yeah, I don't need to. I know, like Terraform is nice. Terraform manages the state, so I don't have to. Prerequisites assumes I'm familiar with kubectl. Yeah, maybe. But you are. That's yeah. I have a friend. I have a GCP account, gcloud SDK. I do have these. Yeah, kubectl.
Okay.
Let's make sure, just because I'm not 100% certain this is actually a thing. We don't need this one, and we can go. Yeah, by the way, Hono sucks.
Oh, really?
It made me so sad yesterday. I mean, it doesn't suck, but like the whole web API native thing does not really work because you just things break, basically, especially around crypto.
Dino is pretty cool. I like Dino.
I mean, I really want like something that I can deploy on Cloudflare, but like on Cloudflare workers, but never mind that. Like,
oh, okay, you mean like a serverless?
yeah, if I go for serverless, I want something that's like fully serverless. But yeah, where they
Dino has
their own. Yeah, their own edge network, but then they serve you like they charge you money for static assets, and like Cloudflare gives it for free, so you know. Yeah. And I'm not running. I'm usually trying to run projects with as little incurring as little like running costs as possible. Yeah, let's call that, I don't know, Kubernetes. Yeah, sounds like a good name. And we said brew install Kubernetes CLI. Should be installed. Yeah, this
kind of struggling because of all of the crazy stream stuff that we're doing.
Probably a little bit, but we're gonna ignore that and just let things go. That's okay. I don't know why did it hang, but yeah, it's running. Yeah, we can continue now with like everything else. So initialize Terraform. Oh, we're actually cloning a template. Interesting. Should we read what's in the template?
Yeah, why not? Let's go to the Git.
Yeah, let's do that right here. And then cd into the thingy and... Yeah.
Oh, I didn't know it does that. Okay.
GHBrowse is a nice CLI. I mean, like the GitHub CLI is quite nice, by the way. Like it has a lot of like nice comfortable features. It also like it can handle your SSH key exchanges if you trust it to.
Okay. Do you want to click dot?
Yeah, we can set up VS Code. By the way, I'm not a VS Code fan, but we can choose whatever whatever editor you prefer, if that makes a difference.
I'm happy to use both. PyCharm has better support for Helm and Terraform, like syntax, and stuff. But the VS Code Kubernetes extension is amazing. It's not an extension built in, but whatever. Okay.
Okay, so we are going to. Oh, sorry. Let's put your face somewhere around here. Yeah, this. I'm gonna move your face around a little bit during the stream. Okay, so what do we have here? This repo is a companion repo to the tutorial containing the Terraform configuration files. This sample repo creates a VPC and subnet for the cluster. This is not required, but highly recommend to keep your GKE cluster isolated. Sounds reasonable. Like I wouldn't like want to expose like my control plane to the world, probably.
Yeah.
Yeah, so here we have a VPC, nothing fancy. Yeah, like no syntax highlighting. That sucks.
Yeah, no, so you get the Terraform extension, which is official. If you go to the extensions.
Is that working also on the like GitHub.dev?
Many do. So
Interesting. Okay, so this one probably, right? The one
the one
that's
with 2.5 stars, or the other one that is not official, that's 4.5, whatever you want.
I think like the HashiCorp Terraform is like the HashiCorp thing. That's
Yeah,
yeah.
whatever. All right.
Yeah. And if we go back to this one,
All right.
okay, we're a little bit happier now. And what do we have here? So we have a GKE password username, number of nodes. Okay, so what are these? Is this like the master password for the cluster?
No, first of all, what you're reading is the description, right?
Yeah, I mean, yeah, I know.
Okay.
These are variables. I know. I know. What I'm looking at the variables because I want to like see what inputs does this have, not even like what resources does this provision.
Right. So it needs your, I don't know what the GKE username and password are.
Yeah. That's like I'm confused about that, but it says something. Oh, if we just would have read everything. Okay, so Kubernetes provider. What the hell is this?
Certificate, cluster CA certificate. The Kubernetes provider is the official Terraform GKE like interface, right?
Yeah.
I don't know what the username and password are. Like, I don't know what that means.
Okay, so I think
go to
let's.
the Terraform website. It'll have much more of an explanation about what the password and username are. There's a link down in the commented out code.
Yeah. Yeah, so it's basically just back to the tutorial.
I wanted it to link to the actual provider.
We'll find it. There it is, like here.
Okay.
Password. HTTP basic authorization. Why enable this thing?
Wait, can you go up a little bit? Because I think there's a tab there to pick GKE in the top of this page.
Yeah.
No, in the Kubernetes provider page.
Oh.
Yeah.
Yeah.
Okay.
Oh, okay. So, but I think this won't like change anything significantly, but maybe it will.
Some way to authenticate into GKE, basically. That's the
yeah. So, but we are getting ahead of ourselves. Like we got just confused by reading the wrong variable at the wrong time. So let's try to keep on track. What we have in the GKE Terraform file is basically Google Container Engine versions. Just okay. So that's just the GKE version.
You should know that Kubernetes, I think 127 is the newest version. So I assume the GKE version follows the K8s
128, but yeah, that's like 21 days ago. Yeah.
Like we're still using 126, and it was and 3 months ago we were still using 121, which is really old. But yeah. Okay.
Yeah. Okay. So here we have a container cluster, apparently. So these names they still like mean not a lot to me because I'm not familiar with like all the terminology of GKE. And let's see what else do we have here. Node pool. So a node pool, I'm guessing, is like this is like the pile of resources that like the cluster can provision from, or
look. I can't say. Some of these could be GCP specific, right? Or they could be GKE or EKS. Like there isn't enough information like in this file. Like we would have to read the provider documentation to see all of these. The meaning of all of these keys, right? That's basically.
Oh, I think. Oh, okay, so I think not. This is the actual like these are the primary nodes. Okay, so these are like these are going to be like our actual machines that do the control plane stuff. I think. These are basically just probably like N1 standard is like the one like the high performance machines. That can probably do like they will manage the cluster basically.
I assume it's like a basic Cascade Lake or whatever.
Yeah, I'm probably even gonna downgrade these to something that's lower cost. Yeah, because like we're not gonna like do something fancy here. Outputs, versions, Terraform. Yeah, okay. So this is not like super interesting. Here we have, what is this? RBUC YAML.
Yeah, the roles and service accounts. This is how GKE can access resources within Kubernetes or outside of Kubernetes. Yeah.
Okay. Do I need to care about this at this point? Probably not, right?
I don't know. I assume it'll explain.
Yeah.
Way, but...
Yeah. Okay. So here we have CD'd into this. This VPC configures like the VPC as we've seen. The GKE configures the cluster. And we've got our TFRs, versions. Yeah, everything here should be fine. The only thing I will probably change. Okay, so let's actually start PyCharm in this folder. So we'll have like a way to actually watch this. By the way, is the zoom level okay?
It's fine. I would I think make the project window narrower.
Yeah, this one. Yeah, sure.
Yeah.
Anyhow, the only thing that I would want to do here before we actually, where's like there's supposed to be like a main entry point, right? Or something like that. Like the Terraform is sort of flat, but you need to like have your providers somewhere here.
I don't remember. Yeah, Terraform is not the main thing that I worked on. VPC.tf, versions.tf. I think if you just do Terraform init, that it'll tell you what you're missing. That's the best way to...
Yeah, okay. So this is the one I wanted. So I wanted here for the store, like the backing store, to be GCS bucket.
Oh, wow. You're really know what you're doing. Looks like it.
I mean... I'm trying to like be not completely oblivious to the fact that like if I want this to be somewhat remotely similar to a thing that I would actually use, then I need to actually try to make this like serious. So storage, I think I have yeah, that's not the one I wanted. I wanted to go to my cloud storage. Cloud storage. And create bucket. And that's infra state. SUF's infra state. It's important that I've actually provisioned this under a different project. So whatever Terraform does, it will not have actually access to destroy this bucket. If I, yeah, like you don't want like the circular chicken and egg thing. Yeah. Okay. So let's see what can we do here. I think like dual region is actually even like one region is like enough. US East. Auto class, sure. Uniform, fine grained. Object versioning.
I've honestly only ever used S3. Really.
What?
I've only ever used S3.
It's truly like
basically the same.
Yeah, truly similar. Like there's nothing fancy here going on. So yeah, I have a bucket now. So let's actually use that one. So we can just paste that in here and prefix Terraform state. That's going to be actual SUF's infra Terraform state. If we'd have more than one project, then we'd want this to be separate. So yeah, SUF's infra is the project ID. Mm-hmm. So now I know like this is not going to like be overridden by other Terraform states if I use like multiple projects. Okay. Anyhow, let's try now Terraform init and initializing the backend successfully. Wow, the fact that it's successfully like initialized the GCS without thinking about it is amazing. I wouldn't have believed this would be actually a thing. Perform, infra. Damn.
Yeah, that was painless. Amazing.
Uh, definitely not what I would imagine. But it is super important because this is actually crucial to like keeping like a clean state where like the state of my cloud is not managed by my laptop.
Terraform, like the magic that I saw was when I provisioned an EC2 machine, you like the same EC2 machine basically using like a document that I saved half a year ago, and all I had to do was Terraform like apply
Apply,
basically.
yeah.
That
Plan
was
and
just
apply,
perfect.
yeah, yeah.
Yeah. That was
Uh,
amazing. But there's a lot to say against it too. So
yeah, I mean Terraform isn't perfect, but it is definitely like I hate like the idea. This one. This is what I wanted.
yeah,
Yeah.
okay. Yeah, I hate that stuff. I also hate the thing that macOS does.
DS store.
Yeah, yeah.
DS
I've seen
store.
them 100 times. Like,
Yep. Yeah, yeah. So here in my favorites, I try to have like a template that basically ignores everything, but apparently like they make it harder every time. So I need to actually comment out the dot idea. Anyhow, we can just say initialized with GCS backend.
nice.
Yeah. So moving forward, if we go back to here, what we can see is update your Terraform TF vars. Okay, so we should do that. Replace me. Awesome. SUS infra. That's a nice project name. And US Central, US East, right? That's the like the one. US East
I
one.
don't know in GCP. I don't know honestly.
I think US East is like the. I think US East one is like the zone. US
Yeah, yeah.
It,
It's usually West Virginia.
US East one GCP.
It looked like it. No, wasn't that it?
Yeah, but I mean, I didn't see Virginia, South Carolina. Yeah.
North, yeah.
Oh, so US Central one is I think the like GCP largest data center. What is it? How do you?
Called? Availability zone or something.
So AZ is like is somewhere like like below the region.
Did you see that AWS had a Lambda failure for 3 days in US East 1 in the biggest one?
Really? Wow.
Yeah, that was like 2 months ago. Yeah.
Interesting. Wow. It's quite amazing. I know how to test that. So I think cloud run load testing, and now it will tell you like where to test US Central one.
Nice. Okay.
Yeah.
High quota limit.
What?
Offers a high quota limit. Okay.
Yeah. Yeah. Do you know how I discovered this? I had to load test my app and like on a European zone, and it failed miraculously. Like it just choked up and didn't work. Like, by the way, that's quite sad. Like I really didn't expect like that 10 machines with 10 cores and 10 gigabytes of RAM would fail like one machine attacking them.
What failed exactly?
It just couldn't like keep up. Like the latency just spiked up. Like requests weren't returning, basically.
Ingresses weren't
like super low load. Like just a very simple request that just does one database, one subsequent call and one database insert. What?
Basically a health check.
Not a health check, but this was like an actual post endpoint that I needed it to work, but I needed it to work, but yeah, it wasn't that good. where were we? So US Central 1 is the one that we want to test against. So yeah, that's the one, Central 1. And let's continue. gcloud config get value project. Why do we need this one?
To understand what project you're running on right now?
Sure.
Okay. Yeah. Okay.
Yeah, like initialize Terraform. We've already done that.
Maybe you should do that again because you've set the project now. Maybe.
I think it's probably not important because this is a variable, not like we haven't like done anything yet. Like this is there's no state yet. That's what I mean. Like we have an empty state at this point because we haven't like even introspected into the state of our cloud.
Right. Okay.
Yeah, but yeah, sure. So we have our TFRs. Provision the GKE cluster. Terraform apply. Okay, so let's try to actually make this work.
Well, Terraform plan first.
Yeah, definitely.
Although it'll ask you
what
if there was no. I think it would have asked you anyway, but
probably not. By the way, service disabled. Compute Engine API and Kubernetes API.
You have to turn those on?
Yeah.
That's weird.
That's not weird. Like you don't want to get billed, like surprisingly. So what we can do is actually have the Terraform actually enable the APIs for us.
That would be a good idea in production for sure. Yeah.
What?
That would be recommended in production for sure.
Yeah. So actually, let's maybe even do that because I mean we are here to try to make this kind of work. So let's call that services. .tf, and we just need to have a resource Google service if you think I recall project service, I think so, and now we can have the GKE API, and the service is going to be, let's try to pretend this is actually true.
Okay.
And resource Google Project Service, and this is going to be the compute API, and this is going to be compute@googleapis.com, and this project is going to be the same project. Okay.
Copilot.
What?
I think Copilot is doing a nice job.
Yeah, I mean, Copilot is really good for mindless stuff like that, and like recalling like the prefix of the APIs from Google. But that's only. Let's actually put Copilot to the test. Like, what is the actual endpoint here? It says container, not GKE.
Go back for a second. Is enable a link or a button if you hover over it?
It's a button. Not a link. I mean, yeah. Anyhow, okay. Let's just move on with this one. So this, I think, will, if we now plan this, let's see if it can resolve service disabled.
Which one is disabled?
Retrieving available cluster versions, Google API. Has not been enabled for Project SUFS Infra. Before it is disabled, enable it by visiting the thing. So maybe we can actually try to do something like inject a dependency here. So where's the cluster itself? This is the one. So we can have a dependency depends on what was it? How did I call this one?
GKE API.
Okay.
Would have to be the service, not GKE API. No.
Yeah, but I think it's like resource. Yeah, I think it's supposed to be like something like a resource, but so it's not var.
Which they couldn't just do this in Go.
Because then everything would have to compile and work, and that would not make you happy, right?
Oh, a subset of Go.
Like Bazel is a subset of Python, like Starlog.
Just do it good. I don't know.
How do I actually let it, how this is a resource? It has a name.
Yes.
I want
And this
to
would Google it, yeah.
what?
And this
Yeah,
kind of
Terraform
depends
depends. Yeah. Depends on meta argument. Resource depends on. Where's the actual?
call.
Yeah, it just depends on
Yeah, there
AWS.
we go.
And if we go and copy this,
maybe you need to do. You might have to do outputs on the same file, so both files recognize it. Maybe I'm wrong. Maybe you can depend on without.
so see that we just need to reference the actual name of the resource and then the name. Yeah.
Okay.
So we need to have this one here. So where was it? We were here, and it says GK API.
Okay.
And now, if we try to plan again, will this work? By the way, we can just try to apply it, and it will maybe work.
Yeah.
Okay, it's taking more time than usual, so maybe it's actually like kind of working.
Okay, what doesn't it like? Container dot googleapis.com.
Yeah, so let me actually. Oh, I see. So even the introspection of the API is we need the API to be enabled. We just need to probably. Anyhow, let's just then manually enable it and not think about it too much.
Honestly, I think I doubt that there's no way to bootstrap this. But maybe I'm wrong.
So yeah, but this is like the spot where we're actually wasting more time than actually like getting to the point, which is where I'd want to us to actually stop and think about how we can utilize both of our time better. But you are correct that actually making this fully working is important. Like fully bootstrapping from Terraform should be like a thing.
That's the point. So yeah.
I think what we could have done is like comment out the GKE cluster, enable the APIs with Terraform, and then on another revision, like bootstrap the cluster.
Maybe, yeah. I've had to debug providers before, so.
Yeah, I mean, this is basically like Terraform should have been smart enough to know that if we try to enable the resource container.googleapis.com plus a GKE cluster, they depend on each other, and that should work if we and we even like explicitly listed the dependency. So
I don't know, maybe I'm just missing something, I assume. Yeah.
Yeah. Anyhow, we are enabling this. This is going to take a little while because enabling APIs on Google is somehow slow. Probably also on AWS.
Because it's creating like 350,000 database records in their database and like distributing them worldwide, I assume. So.
Yeah. But also, I mean,
do better.
Yeah, exactly. Yeah. So we have our API enabled, and that should do a lot of the work for us. And now we can plan again. And this should magically now display us a plus only diff.
Yay!
Yeah. So let's see. We have our VPC, our subnet, our cluster,
Okay.
and a node pool for, well, everything. Oh, I wanted to downgrade this machine.
Yes.
That's going to be a very costly thing if I forget to do that. And
I don't think so. I doubt that they picked like a crazy high performance machine for the demo. I assume it's like a Cascade Lake, you know?
So
It looks
first of
like
all, US Central one, right? Iowa. So this one is one vCPU. It's I'm not sure which machine is this. So N1 is like the standard machine, but
oh, it looks like it's Skylake. No, sorry, it looks like it's Cascade Lake. It looks like the last one is Skylake. I don't know.
Skylake platform only. Yeah. Yeah. So this one actually. First of all, let's zoom in so you will be able to also see that. But I basically just wanted to go with like the E machines, like the E2 cores or whatever it is, like the cheapest VM you could buy.
Yeah, although you might it might be like prudent to use a machine that has enough RAM for running like the Kubernetes brain,
So
basically.
eight gigabytes is not enough for fucking Kubernetes. Yeah, I mean that's
I don't
crazy.
know. We'll see.
So N1 standard, just so we'll actually check, like the N1 standard has only 3 gigabytes. So I think like going with the E2 standard should be nicer. By the way, this is like 4 cents per hour.
Yeah.
Yeah, that's not expensive, but not cheap. And the E2 one, not N2, E2.
Honestly, I would just probably Google GCP Kubernetes cheapest recommended engine. Recommended.
Actually, that's more expensive. Interesting. Oh,
Like,
there is like the E2 small and micro, which is for some reason are not shown here. Here they are, 1 cent per hour. That's the one I want. Or maybe let's go with 3 cents per hour, which is half the price and should be.
I would go with 4 gigs at least. Yeah.
Yeah. So yeah, let's go with E2 medium and not think about it too much. But we also probably want to like configure their disks because probably Google will upsell us with some fancy SSDs.
Yeah, you just want the whatever block storage or whatever.
Preemptible, no. And disk size, disk type. Oh, yeah. So persistent standard is not balanced. Like the default is balanced, not standard, and balanced is an actually quite high performing disk, and it's quite expensive. Like I've had just recently, like for one of my clients, I saw like how expensive like the default Google machines cost you actually if you forget them on. Yeah. So I think 30 gigabytes is enough, right?
Yeah, that sounds like plenty. Yeah.
Yeah.
I think I have to go, sadly.
You have to go. Okay.
Yeah, yeah. But I'll be back. Why don't you tell me when you're streaming, and I'll ping you whenever I'm available. Yeah.
Yeah, awesome. So I'm gonna just continue this stream and let's. I will actually try to like get
I
to.
heard. Sorry.
I'll try. I'll try to get to an actual like provision cluster, and maybe tomorrow we'll actually try to run some workloads on it.
Okay. Well,
Awesome.
sounds cool. Okay.
Awesome. Bye bye.
Bye bye. See you later.
Awesome. So we are going to continue now. What we have here, as you've seen, is an E2 machine. We are just trying to be a little bit cheaper than like the default that Google provisions for us. And do we need anything else on this thing? Probably not. Yeah, so let's try to plan again. Yeah, so now we have our PD standard and everything is like a little bit more known. Local SSD count. Yeah, known after applied. That's not good. Local SSD count 0. Yes, please. Logging variant default E2 medium. What else do we need to see here? Probably not a lot. Node config, size disk, gigabytes. Yeah, so let's actually clean everything. Let's look what we have. By the way, like planning and like making sure everything looks good is really good to make sure that nothing crazy is going on. Subnet, container cluster. Yeah, let's apply. Yes. And we are now provisioning our own cluster. So this one should be actually up and running in a few seconds. We're creating first the VPC and so the GKE API, it's already created, yeah, because, well, we've done that. We should have also disable on destroy false, and also on this one disable on destroy false. This means that when we are shutting down the cluster, we are not actually disabling the API. This is quite useful. And error, insufficient regional quota, satisfy request. SSD total gigabytes requires 300 and is short 50. The quota, project has quota for 250 available. What the fuck? So with container cluster, why do we need, why is it creating 300 gigabytes? Why is it trying to create 300 gigabytes of like SSD storage? I haven't requested that. Let's figure out what the hell is going on. So this container pool is one thing, and now the container cluster itself. Let's actually storage. Wait, if we look at the plan again. Where do we see SSD? Local SSD count 0. That's the one I just requested. So where is that 300 gigabytes coming from? The request requires 300 and is short 50. But which request? Creating the cluster itself. Container cluster primary. Yeah, so compute engine API, current usage 2. Subnet region, usage 1. We don't need this anymore. So filter region. Insufficient regional quota to satisfy request resource. This is the total gigabytes. Haven't requested anything. Terraform plan. So the only thing left to provision is not even the nodes, right? Oh, so no, these are the APIs. So this is just going to be the state change that we've seen now. Changes to output, cluster, host. So let's, I don't know, initial node count, primary 1. Okay. Let's comment this out and be sad about the amount of money Google will be billing me. Yeah, and apply. Yes. And it says the same thing. So it's not about this one, disk size gigabytes. Do we need here to like storage? Ephemeral storage local SSD config. That the one? Okay. Any more SSDs that I need to find here? Advanced machine features. Threads per core. No, that's not important now. The number is probably, by the way, 2, but like, what the hell? Node group. Not interesting. GKE node. Anything else? What else is here is in this plan? So that's the primary nodes. Initial node count known after apply. Is it? Is it not like something? Yeah, we are definitely saying this here. So it's node config. What else do we have here? Storage, disk, SSD, initial node count. Let it figure it out. Project provider, node location, network config, placement policy, provisioner, upgrade settings, auto scaling. If Google has auto scaling here, that's quite nice, but like, what the hell is going on here? Okay, let's try everything now with the Terraform. Let's apply this now with turning off all ephemeral storage and like NVMe block config, unsupported block type. Which one? Ephemeral storage config. So why does it offer me to do this? Boot disk, no. Spot, paint. Anything else that's not supported? Okay. Please work. Yes. Creating a cluster. Come on. Resource SSD total GB. And if we go to this one and we actually write this filter. Anything coming up from this? So SSD. Yeah, so the limit is, it is 250. So here in US Central, yeah, but why do you actually, why is it costing me, like, what, why am I requesting SSD storage? I haven't requested SSD storage. There's nothing about this here. So SSD total storage. Persistent disk SSD. Can I raise this quota just for the sake of demoing this? So quotas. SSD total storage. We're going to US Central 1 and show chart. Can I increase the quota, please? Edit quotas. Select one or more quotas to edit. US Central, edit quota. New limits. Enter a new quota limit between 0 and 250. Contact our sales team. 300. Let's go 350 even. Just like submit request. Google, you suck. Asia East unlimited. Interesting. So, can I get this like more verbose, and maybe we'll actually try to understand which resource is doing the thing? Path, auto approve, input true, state out, parallelism default to 10, put true, block false. Don't hold a state lock during. This is dangerous if others might concurrently run commands against the same workspace. Doesn't Terraform have like a debug thing? Try Terraform expressions at interactive command prompt. I wasn't aware this is a thing. This is stock lock on the current workspace. So Terraform. Yeah, this is not going to help me. The hell is going on here? If we update our Google provider, actually, let's maybe Google this. Let's just read the error again with Google. So if we take this and we just paste that straight to Google, then we can say something like, no, nothing here. Resource. They're in the same issue, and I think I figured out what's going on. By default, deci replicates each node pool across 3 zones of the control plane's region. Each one, okay, so disk size. So Disk size, changing disk type to PD standard should... Okay, so if we go back here and we go to the cluster itself, the Google Container Engine, not the version, but this one. So disk type is PD standard, right? But also that's the pool. Maybe here, disk. Cluster, confidential nodes, cluster telemetry, database encryption. Which one is it? Let's actually go. Okay, so it's in the node pool, node count 1. Let's actually go with node count 1 here. Node count, just the 1. We'll then maybe make this bigger. And location, US Central. Okay, this as just, let's interpolate this one, var region dash A, whatever. Initial node count. Container cluster, yep. And also in this one, primary name, release channel stable, node config. Zonal and regional clusters. So let's try to actually have this in a single zone. Yeah. Dynamic management. Auto repair, auto upgrade. No. Lifecycle, node config. Ooh, that's probably the one, or is it? Oh, it's the same. Already have this one. That's disappointing. Preemptible, E2, disk type, PD standard. We need anything else here? Boot disk, SD. Storage. Size, data, workload, metadata config, no. Terraform plan. Node count exactly 1. And max pods per node, known after apply. Manage instance group URLs, node count, locations, operation, US central. Let's actually go with F, just, I don't know. I feel like it. This is going to be a zonal cluster, and let's apply this. And it will say, I'm going to create this for you, and I'm going to say yes. And let's wait and see if it crashes and burns or not. Still creating, okay. Did we fail differently before? I think we got past the quota thing. Not sure that it's a node count or making this a zonal thing, and it's not now replicated over 3 regions, but we can maybe increase the node count in a minute and then see if it actually fails or not. But this looks good. I mean, looks slow, but still something. So our Kubernetes API, it is now on, and we can actually maybe see something's going on here. So if we go to the console and go to Kubernetes engine, we have a cluster going on. Ooh. Status configured. Okay, so our cluster is being deployed. That's nice. So we are going to now increase the number of nodes once it's done, once it's considered done. Cluster creation can take 5 minutes or more. I like we're not going to commit to saying it's going to even take 5 minutes. But this is nice, like this is actually happening. Wow. Yeah, they're serious about this is taking 5 minutes. Health checks. Okay. So we are now just waiting for this to basically completely boot up. And once it's completely online, we'll try to increase the cluster size. And this is going to be, if we succeed in doing this, then we'll continue tomorrow with maybe actually trying to run some workloads on this cluster. And it's definitely going to cost me money before we actually get this working. Wow, so many buttons to click. God damn it. Actually, let's maybe even look at the quota here now that we have our GKE API. Is going to the docs. Why is it going to the docs? I want the actual API. We were just there. We go back here and we go to the Kubernetes engine API. We click manage. We can look at the cost or quota. Actually, let's look at the quota. That looks probably like the thing that we'd actually want to look at. So we have our write requests per minute. Current usage 1 per minute. Yeah, that's not interesting. Reads 600K. And the compute engine API. Console API's dashboard. Traffic, median latency. That's not interesting yet because we have no traffic or anything like that. Enable APIs and services. We just want to go here to the compute engine API. It's already enabled. I just wanted to look on our actual usage now. Loading contents. Yeah, 5 minutes or more. So we are sitting comfortably at 100 gigabytes of persistent SSD storage now. Where is it coming from? I'm not sure. Let's actually try to debug this while our provisioning is going on there. So let's go to our compute engine. And we have our default pool, which is the one here, and we have our disks. So this is in use by our infra. So it completely did not respect its. Why is it PD balanced? I definitely wrote PD standard. Have I? Yeah. Is this at least an E2 medium machine? VM instances. What kind of machine is this? It's an instance of what type? Is it E2 dash anything? E2 medium. And our disks are. We have two disks. No, we have just the one. One boot disk, which is a persistent balanced persistent disk, 0 balanced PD disk. So this is actually, this means this is just not actually respecting not this one and not this one. I think we should open. Let's actually like open a bug on this. To do West maybe. Issues GKE Terraform Google modules SSD. Yeah, HashiCorp Google PD standard. Do I actually know how to make this work? Let's see. This is probably written mostly in Go, is it? Autogen, samples, scripts, modules. Here we have our services. Where would we find this? Let's look for the string SSD size GB. Yeah, so these are supposed to be running. The smallest size allowed is 1 GB, 10 gigabytes. Wait, did this finish? It did not. Is this still running? Like, is this going to finish at any point? GKE clusters. Okay, so it's fully provisioned now. So, oh, okay. So I guess I sampled it at the right time. Primary nodes still creating. So where's the setting for the actual cluster then? So here within the cluster, we have our node. Oh, disk size, gigabytes, also 30. Disk type, well, we know it's PD standard now. Can we resize this? Well, this will definitely destroy our cluster, but now we can be sure this is actually going to work as we expect, probably working. And we can bring this back to 2 nodes. And within our cluster. So let's actually make this, again, let's move this. I'm basically going to destroy the old cluster. Probably this is this is what I believe will happen from what I'm doing here. And this will probably just provision a new one because I'm like moving stuff around. And specifically, I'm moving like cloud resource. That's probably not. Yeah, so, okay. Anyhow, we can just have this one. And this is complete. And now we can plan and try to downsize this to something that's not costing me a lot of money. And then we can safely make this shut down and like go somewhere else. Yeah, so this is going to change a lot of stuff. Must be replaced. That's all right. I'm okay with replacing everything. And yes. Forces replacement. Yeah, that's the one that's forces replacement, not really the SSD, this SSD one. This will be replaced, and also probably the cluster itself will be replaced. Yeah. So is it waiting on me to say yes? No. Okay, so it is now destroying our old pool and creating a new one instead of that. Of course, this is the only reason we can just allow these actions to be performed safely is because we're not still doing anything but the cluster. We need to like apply more thought to doing these kinds of migrations later on. But hopefully what we will do is basically we will be able to provision once we have our our cluster provisioned, we can allow Kubernetes to provision resources on behalf of us instead of us like doing this manually on on Terraform. But anyhow, this is now looking good because it is now destroying, and then it will re-provision a new thing. And while we have that, let's actually maybe scroll further down in our tutorial. Warning, cluster not running, API may not be available. Yeah, that's not a thing. And once we will have our cluster, we can run kubectl apply, which will be Kubernetes dashboard AIO deploy recommended YAML. I wonder what will this be, but we will find out. But also, how do we connect to our actual dashboard? Oh, get credentials. Okay, that looks good. So cluster host, cluster name, project ID, US Central 1. Still destroying. Yeah, I think I'll be back in like 5 minutes because this is going to take a while probably. Yeah, so I see we're still on the same spot. So let's see what else can we actually do now that is going to be interesting. So while this is destroying, we cannot run still kubectl. So there's no bug here. We just forgot to configure one more kind of node. But that also means that basically every cluster that Google provisions by default is available over 3 zones, which is kind of crazy when you think about it. This is like a really good way, first of all, to get some money out of you. But apart from getting some money out of you, this is actually like way overkill for most things that you would actually deploy. Usually like one node, one server is enough. I'm doing this because, well, I'm curious how to run these things, but this is like quite heavy-handed, basically. And now when I think about it, this also needs to be an E2 VM, right? Like I haven't said like which VM type is this. So machine type, E2 medium as well. E2. What else have we made here to make this be cheaper? Yeah, env size, local SSD count. And remove default node pool. Can't create a cluster with no node pool defined, but we want to only use separately managed node pools. So we create the smallest possible number of node pools and immediately delete it. Wow, I can't believe this is an actual thing. We just provision something to destroy it in order to make this cluster boot, because we want a separately managed node pool here. And this is why this is actually even worse, because we don't need this one. We can have it as like the smallest thing, because we just need to provision it to delete it. Amazing. And the fact that like the default tutorial doesn't even mention that you would run up into like quota issues with provisioning to a node just in order to delete it over 3 separate availability zones is crazy. Okay, but we are done destroying the previous cluster and we're now provisioning the new one. If we go back to the console, let's figure out what's going on with the cluster. So 3 nodes. Ooh, interesting. Yeah, so we have our, we are on B, C, and F availability zones. And we are now running the health checks. I think now everything is a little bit faster, I hope at least, because, maybe Google's databases have a little bit more knowledge of like this account and like the actions that it's doing. Maybe things are a little bit hotter in cache here. Anyhow, it looks like it at least configured and deployed quickly or faster than the previous one, even though we definitely did more work than the previous things that we've done. If we go to our compute engine dashboard now, we have 3 nodes, each one in different areas. And in terms of disk size, we have 30 gigabytes standard persistent disks. That's awesome. That's actually useful. Like we don't need more than that. This is still going to cost like actual money here. If we go to our API again, so compute engine API, Not the docs, really. I really just want to like APIs and services. Library. Compute. How do I get to this one? Like I want, okay, so it's APIs, API, enabled APIs and services. How do I select this one specifically? So first of all, let's look at the usages now. So we have in use IP addresses, limit 4, quota 2, networks 2 for some reason, CPUs. So we have 12, all regions. That's all? Wow. So low. I probably need to actually request something. Okay, never mind. Persistent disk storage. We have quota of 2 terabytes and 60 gigabytes provisioned. That's not true. I think we have provisioned 90, but maybe it's not counted up yet. Managed instance groups. 2. VPC subnets. Operation, read, request per minute per region. I think we're good. Still creating. What is it doing in those health checks? What's going on there? Kubernetes. Yeah. So here's the cluster. Health checks. 83 logs. Okay, so it's doing something, apparently. So these are the logs of the cluster itself. Okay, so this looks provisioned now. So probably this will, in a minute, also tell us that everything's fine. Status. Deleting the node pool, default pool. The values shown below will be updated once this operation finishes. So is this like a thing that Google itself knows about? And so to prevent this, you should always create your cluster with hard-coded cluster versions to the last version available. So this means Google is managing the master, meaning that if your master is not up to date, it will be updated with the last version. Allow Google to limit the number of versions currently managed. And because we're in the zonal mode, okay, so this is quite important to see that. That means that in order to like having multiple availability zones is important if we want to upgrade things and we want to do them not in unison. Then we can have like, we can shut down like one node, upgrade it, then shut down another, upgrade that one, and boot up these two, and basically have each time we at least have like one zone that can take up the load, maybe. Okay, so we have created our cluster and now it is creating the pool. Okay, this looks good. So this should now have a green mark, right? Because it is created already. Or maybe I have missed something. Still being updated because it has 0 nodes. That is because of our crazy configuration. I'm not sure. But I can now see why this actually costs a lot of money, because we are provisioning a lot of resources just to boot this thing and to get up and running. This is amazingly slow. Yeah, I think I'm gonna be gone at least until this is actually done. Yeah, so I'm back, and this looks like it is still not finished. And at this point, I'm wondering whether actually something is happening or not. So let's go back to our cluster here, and maybe even, you know what? I'm gonna interrupt this and then apply again. Then this will introspect to the actual state of the cloud and continue from wherever we are actually at. Refreshing state. Definitely more sluggish than I would have hoped it would be, but we'll see in a minute. Wow. I would not classify this as a good experience, but at least we are learning that managing cloud infra is shit, which is a good lesson for all of us. Wow. This is just not good. Vested, used, allocated, allocatable. This is just not good. How did we get to 4 nodes? Like, this is weird, but yeah. Exiting immediately. Note that data loss may have occurred. That's all right. And let's plan again. As Google API error 412. At least one of the preconditions did not hold. Terraform requires a state lock to protect the state from being written. We have no other writer, so let's go with force unlock. Manually unlock the state for defined configuration. This will not modify your infra. This command will remove the lock, the state of the current workspace. Lock ID. Yeah. Yes. And Terraform plan. Let's see if our infra is broken or not. Refreshing state. Primary nodes. This is probably still going to fail or hang on the same space. What the hell is going on with these nodes? Auto scaling off, allocatable memory. So 4 nodes. CPU requested. Nothing. Milli CPUs. Oh, allocatable. That's actually not nothing. That's like half a CPU here. That's quite a lot of cores for doing absolutely nothing. I destroy this. Storage. Premium row storage class. PD standard, PD balanced. Storage classes. Volumes. Observability. Observe, this is wasting my time. Okay, let's figure out what can we do with destroying this. This is like terrible. We have no workload running on this, and we definitely have not done anything fancy. So I don't know. I'm just gonna destroy things manually and then let Terraform handle the fact that I fucked this up royally. So first of all, stop. Second of all, once they are all stopped, I should have just directly deleted these and let the GK provider like handle the fact that everything here is destroyed. So stopping instance. Wow. This is excruciatingly bad. Deleting. Please delete. Just do anything in your power to just destroy and make this go away. These templates, they cost me anything? Can I delete them? They are used by an instance group. All tenants, nothing. Machine images, nothing. TPUs, nothing. Hopefully. Yeah. No CUDs, reservations, disks. Yeah. So this disk is being deleted. That's good. And delete disks that are attached to an instance. So can I detach them, please? Snapshots? Snapshots? Images. Okay, so things are slowly stopping. Okay, so these are just like images that I can replicate. These are not things that are interesting to us. Or are they? Yeah, so, okay. We are deleting some of these instances, and they are probably also rebooted because this is how the GKE crap works. Yeah, and now Terraform plan again. It will say this is locked, and then, oh, it's not locked. Primary nodes, GKE Kubernetes cluster. Please just work. Why is this taking so long? What's actually running here? Provisioning. Status provisioning. Oh, I see. So how do I stop it from provisioning? I want this to just crash. Status instance group is resizing. 0 to 2. Interesting. So that's the one that's actually doing something fancy. So let's delete this group. Delete. I am definitely, wow. Like, okay, so this is my fault for replacing the cluster with a bigger one. The server was not able to fulfill your request. Awesome. So this is the one that we just deleted. That's good. So insufficient quota to satisfy your request. Not all instances running IGM after 22 seconds. Okay, cool. So we can now plan again. GKE quota exceeded. And it says waiting for resuming GKE node pool. Warning status. Okay, cool. I'm just gonna delete this clusterfuck. Everything, just destroy it. We are going to pretend this does not exist anymore, and we just plan again. Or actually, maybe we need to wait for this to actually disappear, because I want this to not actually exist. Yeah, so this one is being updated now. And by updated, we mean deleting, it's just deleting the node pool, not the cluster. So here we have something. Yeah, Terraform destroy. I'm just gonna re-provision this before tomorrow. This is going to fail to destroy. This is going to be amazingly bad. Limit for expected to running 0. Instance groups, updating. What is it updating? Who allowed you to update now? For instance, update parameters. Rest monitoring errors. Hopefully a lot of errors. give me something. Yeah, this is me manually deleting stuff. I need to charge my keyboard. But I now understand why people say, and using Kubernetes is a world of pain. So much weird shit happening here. Terraform destroy. Please just delete the thing. Overview. Updating. Deleted. Oh. Failed to load. This will remove everything. Oh, okay. So actually, no, that's not. Maybe now, if we actually try to run this, yeah, so no nodes, no nothing. Awesome. Perform, apply. Actually, let's plan, let's see exactly what we're gonna get. Okay, so nothing to destroy. Oh, node config. Forces replacement. That's all right. Primary cluster must be replaced because of this node config. Okay, so let's try to make this work. Terraform apply. Yes. Okay. I will be back in a few minutes. Now that's destroying the cluster and re-provisioning it. But wow, this is just has been terrible. This has been just terrible. Yeah, be back in like, I don't know, 20 minutes. but this is just things being terrible. I just want to destroy everything and just maybe start fresh in the next stream, because this is wasting everybody's time, mine including, and yours as well. Yeah, so actually maybe even let's go with we're gonna go with auto approve, or how is it done? Perform destroy. Yeah, so I just want to auto approve this destruction and auto approve. And it says that it is locked, and we can just terraform force unlock this one. Yes. And destroy auto approve. Yeah, so I think I'm gonna let this stream go, and I'll see you in the next one where we try to actually provision this and like see this going probably better with no like split brain state of like of this cloud project. So I'll see you in the next one, and bye bye for now.